All right, so this is welcome to part 2 of exponential functions. In this video, we're going to be looking at the graphs and how to write the equation if you're actually given the graph first. So in the first video, we talked about what they were, and then we talked about how we could make the graph if we had at least the function, and now we're going backwards. So on this graph, you see an exponential function, and you are also given a point value. You are given the point 225. So I want to talk about how we would actually go to find that. Let's keep in mind that we know that an exponential function is written in the form of f of x is equal to a to the x. And ideally, we need to know what the value of our base is. Well, if we have the point 225 as we do over here, that just represents an x and a y value, right? This is my x and this is my y. And we know that f of x is another way of saying y, so I could just replace that with 25. And then I need to figure out what a is, but I know that x is equal to 2. So this is what I have written over here. I'm going to evaluate when x is 2, and I'm going to actually plug that in here. And now you see that we're right here. A squared is equal to 25. If you recall, the way to get rid of, and I'm going to actually rewrite this so it's a little bigger, the way to get rid of an exponent is to take its radical. So if I take the radical on one side, that leaves me with a, and I got to do that to the other, and I have to remember to put a plus or minus sign. And what that gives me is plus or minus 5. The reason being is that 5 times 5 is 25, but negative 5 times negative 5 is also 25. So there's two answers. But you'll notice right here that I only included 1 because this represents 5 and it represents negative 5. But 5 is the only answer that I wrote. Can anybody take a guess at why? Think about this. I would recommend you to look at the definition again and then pause this video and think about why would I only include one value. Well, the reason why I would include only one value is if we go back up here to our definition over here, we said that if you look, let's see, I got a purple marker, let me make it green. Right here, we said that our base is not allowed to be negative. It must be between 0 and 1 and bigger than 1. And thus, with the negative base, that causes an issue. It's no longer an exponential function. So this solution, negative 5, can't happen because that wouldn't represent an exponential function, which is why I only end up with one answer. F of x is equal to 5 to the x power. Okay. On the second example, I say the same thing, find an equation of the exponential function, but I'm telling you that it's been transformed. It's been moved a little bit. So when I write a times b to the x plus c, I'm letting you know that some things have been done. You have multiplied a value on the outside. You have your b to the x, which is your exponential function, but you also have shifted this up or down a particular value. And so we need to find what are all the values that go in for a, b, and c. And so I like to use this process called CAB. C, to get the value of that, that is just represented by whatever your horizontal asymptote is. So you would go to your graph and you would look to try to identify what is the value of my horizontal asymptote. So I'm actually going to do this in lime green. And if you look at the graph, you see that there is a horizontal asymptote right here. It's even the dotted line was made for you. Well, what is that passing through? It's passing through 3. So you would know that your plus c in this case would be plus 3. To find a, I'm going to go ahead and do that in purple, you have to use the y-intercept coordinates. So remember that the y-intercept is the point that crosses the y-axis, so that would be this point right here, 0, 4.5. And then for b, you're going to use your other point. I'll do that in blue. Use other point. And the other point that you were provided in this case is 1, 6. Utilizing these things will help you find all of your particular values, okay? So I know that everything is showing up on your screen at once just because of the app that I'm using, but I want you to focus on one at a time. So the very first thing I would like you to focus on is C. So I'm going to go ahead and put my little green highlighter around that. Again, remember all we did was look to see where our horizontal asymptote is. That is at the value of 3, and so we have replaced C with the value 3. That's all we had to do to find C. Okay. For my next one, I'm looking at A. Get rid of that for a second. We're looking at A right here. And in order to do this, we are concentrated on the value of our y-intercept, which is 0, 4.5. So again, remind yourself that the equation you originally have after finding C is you now have f of x is equal to a times b to the x plus 3. And using the y-intercept, you have an x value and you have a y value. And so you see in for x, I plugged in 0, and in for y, I plugged in 4.5. And the beauty of this is b to the 0 is equal to 1, and so it leaves you with just the a. I moved the 3 on over, and that got me 1.5 as the value of a. And so now the second equation I now have is f of x is equal to, we just found a as 1.5. I still don't know what b is, and then b to the x plus 3. So the very last thing I need to do is I need to go figure out the value of my b. So I'm going to utilize the other point, which is 1, 6. And same idea. I'm going to plug in 1 in for x, and I'm going to plug in 6 in for y, and I'm going to solve this equation just as I would any other. B to the first power is just b. Notice that I've moved the 3 on over and got 3 is equal to 1.5 times b. I divided by 1.5 on both sides, and that got my b to be by itself. Okay? And so now the final equation I'm left with is f of x is equal to 1.5 times 2 to the x plus 3. I have provided you with an equation here. I'm going to encourage you to go ahead and stop this video and pause it. Try to work this out. See if you can find the equation based off of this graph, and then I will help you with the solution. So the very first thing we want to look at is C, and C tells us to look at our horizontal asymptote. And I see a horizontal asymptote at the value of y equals 2, and so that lets me know the new equation that I'm working with at this point is f of x is equal to a times b to the x plus the value 2. Okay? And that was finding my C. The next thing I need to do is A, and in order to do A, I got to utilize my y-intercept value, and my y-intercept value is 0, 2.5. So in order to solve that, I'm going to replace y with 2.5 is equal to A times B. I'm going to replace x with 0, and then plus 2. I know that b to the 0 just equals 1, so that leaves me with 2.5 is equal to a plus 2. I'm going to subtract the 2 on over, and that leaves me with 0.5 is equal to a, and that's the same thing as 1/2. I like to keep things as fractions. I don't really like working with decimals. When you get into upper level math, you don't really work with decimals a whole lot, so I like to keep it as a fraction. So this has helped me to find the value of a so that I can rewrite my equation now as f of x is equal to 1/2 times b to the x plus 2. And that is my a. The very last step is to go and look for my b, so I'm going to use my other value. I'm going to take the function that I've created at this point. I'm going to replace y with 4 is equal to 1/2 times b to the first power plus 2. B to the first power is just b, so I have 4 equals 1/2 b plus 2. I'm going to subtract my 2 so that I have 2 is equal to 1/2 times b. And I'm going to divide 1/2 on both sides. And when I do that, that leaves me with 4 is equal to b. I can now write my final equation as f of x is equal to 1/2 times 4 to the x plus 2. And this right here is my final equation. Now I have a question for you. I want to know, is this equation the same thing as f of x is equal to 2 to the x plus 2? Are these the same thing? For those of you looking at this wondering what I did, I multiplied the 1/2 and the 4, and that's how I got 2. So do we think this is the same thing? I want to remind you that no, it is not. This is an incorrect answer. The reason why is order of operations. Please excuse my dear Aunt Sally. If you guys remember this, it's parentheses exponents, multiply, divide, and then add and subtract. The order of operations says you need to handle what is getting or what has an exponent before you handle multiplication. And so you need to evaluate that 4 to the x before you can go and multiply that. In this case, because we don't know what value of x we're plugging in, we can't really evaluate it, and so there's nothing that we can do. So I'm going to erase this and just remind you that they're not the same thing, and that would not be a valid answer. So your final answer should be f of x is equal to 1/2 times 4 to the x plus 2. My last slide is providing you with one additional example. If you want to work on this on your own, you're more than welcome to, but I hope that you found this video helpful and have a better idea of how to find the equations for an exponential function.